Yaskawa.
Thanks for joining us for another Yaskawa Motion Applications Group webinar, and we're going to go into these memory allocation topics in detail, and I'll show you some places in the software that you can view the memory being allocated by your application program, and we'll answer some questions that come up on occasion regarding what to do when the application program seems to be getting too large for the controller. I want to point out this chart that has been added to the hardware configuration manual. It's in section 4, and it diagrams the 3 types of memory in each of the IEC series controllers. So they're color-coded, and we have the flash memory in blue. We have the battery-backed SRAM in green, and the working memory of the SD-RAM, where everything is loaded and run from, and that is kind of the orange color there at the bottom. So a couple interesting things to point out here. Several of the controllers have the same size flash. The 2300s and the 2600s have about 8 megabytes of flash, whereas the MP3200 goes up 5 times and it has 40 megabytes of flash. There's one difference here also with the battery-backed memory size between the MP2300S and the MP2310, and that is the difference between 0.5 megabytes and 2 megabytes for battery-backed data. And you can see the sizes there as well for the other controllers. And again, with the SD-RAM, most of the controllers have 32 megabytes, and the 3200 goes up from there quite a bit, so about 4 times more. Now those are just the performance or the basic metrics there, but there's more to learn about when we want to understand how much memory is available to the IEC application. And then each of these sections is broken out into some more detail on this page. And one key thing to understand is that in several instances, in several occasions, you need to cut the number you see in half. Like we see this note down here under SD-RAM. It appears that you really have available to the IEC application about 350 kilobytes of data for battery-backed retain type variables, but that's not the case because the controller needs to cut that in half to allow for download changes to take place. So you really have a little bit less than 180K that you can truly use for battery-backed memory in the 2300 or 2600. Similarly, that same feature, or a little different feature really, is the case down here in the SD-RAM, and you can kind of, if you can see, the background color is got an orangish color to it in those four squares here. There's some allocation that takes place, and it's dynamic. The user can actually switch how much memory is allocated for the global variables in the IEC application from the default of 1.6 megabytes up to 3.2 megabytes. And I'll show you how to do that if you're unfamiliar, but the trade-offs there are related to how many variables you can add to the IEC application versus how much other memory is available for CAM files, CAM data to be loaded. In either case, I'm going to show you, I think, that these are quite large numbers for most applications, and I have a sample application I'll run that shows what it looks like when it's loaded pretty full. And we'll come back to the screen a couple times. This little chart I've added now here shows a screenshot of what the hardware configuration page will show with an out-of-the-box controller. And so these are the numbers you'll see for available memory. And we take a look at the flash section first. It shows about 3 megabytes. We officially listed this as having 3.5 megabytes available. I'm not sure why there's a discrepancy, but that's the real number I received. And this one's more in line with what we see down here for SD-RAM. We got about 11 megabytes available, and we can see that that's the sum of 7.5 and 3.5. So In discussing memory sizes, there's really two reasons you'd be concerned with that on the controller, and one of them is because you're trying to understand how many cams or how large of a cam file you can put in the controller. And the other topic is when you have many axes or a very large and complex program that requires a significant amount of code. So these were actual questions I received recently from someone trying to understand the potential for adding cams to the project. And I thought they were good questions, so I wanted to share them during the webinar. And how many cams can we have? How many points can we put in one of our cam tables? And what's the memory size where we would store these cams? And question 3, are the cam tables stored in RAM or flash? And to all three of those questions, there's not one simple short answer, as you'll see when I go forward here. Just to quickly review the memory chart again, and to summarize the way cams work, cam data files are handled in the controller. For any cam you would run, there will be 2 copies of the cam table. You will either start with a CSV that you've loaded into the flash file system. Okay, so there's going to be 1 copy of it in the flash. And then when you use cam file select, the controller will copy that data from the flash into some memory area in the SD-RAM for use by the controller during runtime. So that makes the 2 copies, the CSV copy of it and then the binary copy of it in SD-RAM. So the one question previously was asking where did they reside, and I say for any cam you would create, they will exist in 2 places. So I just gave you the first possibility, and that was with a CSV cam file. The second possibility is when you auto create your cam from within the IEC application. In that case, you probably have a cam struct. You're possibly using the cam generator function block, or even if you calculate that cam yourself, that data will exist in the IEC memory in a structure, which will consume memory, of course, and then also be copied using cam struct select to the SD-RAM where the firmware, where the motion engine will use that data for running the actual motion. What's the data type of the CSV? It's not LReal. The CSV is an ASCII file. So that means that, for example, if you had a master-slave pair such as this value in red in the file itself, each of these characters takes 1 byte typically. So if we count all the red characters, including the comma, that's 21 bytes. And you can add to that some kind of line delimiter, such as a carriage return. So each cam point will have 22 bytes in that file. And we can do some other math from that point to determine how many bytes that cam table will take in Flash. But that's actually going to consume more memory than if it were an LReal, because an LReal is 8 bytes for a value, and master and slave would then be a total of 16. A CSV file may or may not be larger than the binary file for that reason. You know, if I had less characters of resolution required from a master and slave, I may actually have less characters than 8 bytes for a master value. If I put down simply 12.45 and that's all I required, then this number could potentially be smaller, but in either case it must be an ASCII value as a CSV file in the Flash. And as I mentioned earlier, CSVs are loaded into the motion engine. There again, that's the 2 copies we would end up having in the controller when we use cam file select. Another question regarding camming was, are the master points predefined in equal increments? And they do not need to be in equal increments. You can do that if the application requires it, but the distance between the points is completely up to you and to what the application requires, because the controller will do interpolation between each of the points you give it. So if you have a section of the cam that doesn't require any particular resolution or detail, then a straight line will be just as good, because we will again do the interpolation between those points, and that's the memory savings there. So question 3, for a 1,000 point cam, is there really 2,000 total points? And that's just the way it's worded, or I guess the question, the way it's worded, is not totally correct, because every slave requires a master and slave data value, and we typically consider that master-slave pair a cam point. So really, for answering question 3, if you tried to have 1,000 detail points in a cam, yes, there would be 2,000 values. Whether it's a CSV or whether it's a binary file in the SRAM, really got to consider that you always have a master and slave together. So to kind of demonstrate some of the realities of making a large program, I'll go to that next. I'll show you the MotionWorks IEC large program that I have here. These are some of the attributes of that program, some of the details about it. What I've done to the controller is I've made some large data files, and I loaded them to the flash. So I have 24 CSV cam files in flash. Each of these cam files has about over 2,100 data points, and if you do the math, or roughly, I just simply copied and pasted one row essentially. So I know that each of my data points is about 22 bytes, and these files end up being about 77K each. And so the total size of those 24 cams is over 1.8 megabytes. Additionally, to make the compiled code larger, I created 21 large POUs that are nearly full to the 64K limit of a single POU. So that's more than 1.2 megabytes right there, just in IEC code itself, which is not to be confused with variables or data space. Also in the IEC application code, there are 68 of these cam segment structs defined as global variables. And if you do some math on the data type definition, which includes the arrays of L-reals and other things, etc., I calculated that each of these user-defined data types is almost 13,000 bytes to hold that cam. And so if you do the math on these numbers, that's nearly a megabyte of variable space just for these cams. So on top of all that, these other facts here, this controller I'm using is attached to 16 servo axes, and it's running 4 cyclic tasks. But let's go see that in action right now. I'll start with the web server. So this is the project archive for my controller. You can see that I'll point out the bootfile.pro is the compiled IEC code, and that is less than half a megabyte right now. I've seen some larger programs over 1 megabyte, but this project also has the cam files I spoke of, so you can see them named here, cam1234.csv, and each of those are the same size because I simply replicated the values to fill the memory space. In addition to the 16 cams that are in here currently, I did have 24 at one point during the creation of this webinar, but I wanted to additionally put in a much larger cam. So I added one called Super Cam, and it is over half a megabyte itself. And Super Cam has 32,768 cam points in it. And I can actually run that cam file. And as I mentioned, we have 16 axes, so of course we have the backup copy of all the servo pack parameters, and those files, when you have 16 of them, start to take up some memory as well. I'll open the hardware configuration, I want to show you the memory pie charts. So this project right now is consuming a large portion of the flash and the RAM, so I only have 10% flash free, given that all those CSV files are in there. I could probably put a couple more CAM files into the flash. And the RAM is quite full as well, and this will shrink as I load CAM files. And I think I just did that before I started the webinar. I'm going to reboot the controller so I can start from that more fresh condition. And it was 12%. Let's give us a moment to let it reboot. I think it's going to be about 19% when I come back. Let me just quickly go to the next slide while we're waiting for that to reboot. I was starting to discuss some of these large CAM files. So how many points can I generate is a common question. And it's not an easy answer given the flexibility of the MPIEC series controller. There's so many options and so many ways to allocate the memory for different purposes. So that's the purpose of my my large project, is to give you an idea of the kind of sizes of data you can fit in there at one time. In order to do this large CAM file of 32,768 points, if you were to do that by creating one in the IEC application itself and sending it with CAM struct select function block, you would need to edit the datatypes definition file, which is in the datatypes toolbox currently. And the reason for that is because our default definition is only for 2,880 CAM pairs. And I'm talking about the y_ms_cam struct. So we picked a nominal size just to be moderate and applicable for most applications. This is certainly editable by the user. And you'd have to if you wanted to get more CAM data points in that way. But this is enough for 8 data points per degree of a master. And it seems to work well for most applications, in fact. Okay, let's go back to the hardware configuration. Yeah, that reduced back to 19. And the reason for that was that I had already loaded SuperCam in here before the webinar started. So I want to point out a couple things here. When you have a very large program such as I have, I get errors when I compile. And I'm getting warnings that my large POUs are more than 80% of the POU maximum of 64 kilobytes. Let's take a quick look at this POU. So I fill this with essentially just simply busy work to show how you can get to 64 kilobytes. Now that's talking about the compiled code, not the variables. There's really only 7, or okay, there's more than 7 now, variables in this POU, but there's not that many variables in here. The warning is about the size of the compiled code, and that is the result of all the math and the comparisons and the nested if statements. And there's some exponent math here. And when you do this kind of thing, and I just copied and pasted it down, there's only about 350 lines, 300 lines. And already it's to nearly to the max of 64 kilobytes. Let's see if we can look at the Infos tab here. That gives us a little more information too. So if I expand this, the Infos tab will show you the size of the data for each of the POUs, not the compiled code, only the data. And let me switch, I have this pasted into Excel, it's a little easier to read. Got it worked on here. This is the message info box for this project. And I've sorted it by size. So you can see where your very large POUs are. And I kind of highlighted 4 of these as having a large amount of variable space. And if you read the words that are in that info tab, it says non-retained data is 810 kilobytes. I don't have any retained variables, and there's some kind of temp data that I think the compiler uses. There are 2 instances of this function block. So it's this number basically times 2. And the same is true with large POU1. There is some degree of data in there. It's because I added the home struct, if we noticed. If I go back to the variable grid for large POU1, there's a lot of home structs in there. And those take up probably around 100 bytes each. And the ones that simply have let's go back. The other ones don't have as much data. They only have the 7 or 8 variables. So any of the other POUs, those large POUs, they have almost no data, but they have a large amount of code. So the next question is, well, where do I see how much code they take up? And that is visible in a different screen. That is visible from the resource dialog window, and unfortunately only available if you were able to successfully download. So this resource dialog box, when you press the info button, contains a listing of the POU's code size and also the variables. So this is a little more comprehensive. And again, I do have a copy of this in Excel for easier viewing. So here we can again see where the most amount of IEC global variables resides, and which of the POUs have the highest amount of compiled code. So each POU can have a maximum of 64 kilobytes, and then you can break it in half and have as many POUs as possible until you would consume the flash and the SRAM area for the entire IEC application, which again depends on other factors such as how many cams you want to have at the same time. But in summary with that, I do have quite a large number of large POUs in the project. A couple more things on this subject. There are at least a few different errors that may be presented to you when you have some issues with memory in the controller. And one of them is this error called exceeded the data area. And so what does that mean? And it's simply that the memory required for the IEC application is too large for the space allocated in the SD-RAM. And that's that orange section we had shown in our memory chart. There is an icon on one of the toolbars in MotionWorks IEC. It's on the hardware configuration toolbar that opens up this window. And this window allows you to select between one of two memory allocation sizes for the variables in the IEC workspace. You can either have the default of 1.5 megabytes, or you can double that to 3.2. And that goes back to the chart where we explain the trade-off there is with the amount of CAM memory that's available in the SD-RAM. So for some users, they may have this set at default. They may start to acquire larger and larger user-defined data types in their project and hit this limit and hit this error. So for them, they can simply use this icon and double up the amount of global variables available for the project, and then they're in much better shape. So once again, we're speaking about the SD-RAM allocation, and the default is really half of that number, right? So 1.5 or 6 megabytes. And if you select 3.2, this will double. This number will double, and then this number will reduce down to 4.5 megabytes, as it says here. So you may also see this message box appear when opening a project. And that happens when there's a discrepancy between what the project memory size is set for and what MotionWorks IEC is set for. And for the most part, I usually click no and ignore this message box when I open a project. And I wait to see if I have an issue when I try to compile and download before doing anything about it. You may receive a message like this in the compile window, that the var group is not plausible. And this is a very cryptic message, but it's a clue that there's a problem with the setting between the 1.5 megabytes and the 3 megabyte allocation. And so then I usually go to the data area settings box and set the setting or toggle the setting and rebuild the project. I just show this box at the left. This is the data area settings. If you right-click on the resource in the project tree window, these numbers are fixed. You can't really adjust these yourself, but that's where the memory allocation is set for the 1.5 megabyte versus 3.2. That's the settings we are automatically setting for you when you click on this icon here and set the values with this box. Another possible remedy to alleviate some of these message boxes down here, such as error in memory management, is to make sure that if you already have a boot project on the flash of the controller, that you do a delete on target, because there's a comparison done when you start a download, and if the new project has a different memory allocation than the existing one on the controller, you receive this message down here, error in memory management. So if you've been in the middle of development with a project of a certain memory allocation and you decide to change it, you may have to do this. You may have to delete on target and re-download with the different memory size. So in closing with this section about memory, there's a good chance that you may have too many large variables defined but never used. I think some users in the middle of development start to create variables and possibly change the name of it or add additional variables without realizing that they are quite large, and then ignore them and leave them into the warnings list. I think on my compiling here, if I compile, I think I have 60 some warnings. It's warning me that many of these are never used, and for me that's because I was just trying to fill the memory, but generally it's advisable to remove these data types or these values that aren't being used. They are consuming memory in the controller, and maybe to the disadvantage of having these issues with memory allocation. And I think one of the best tips we can leave you with on this subject is to recycle large variables where possible. That's not always apparent that that's possible, but that is. And the best example of that is with these cam structs, YMS cam struct. We recently optimized some of our programs that we were doing for rotary knife applications. And let me show you the code where that's an easy optimization to make. So many times if you're having multiple cams, you may have multiple cam generators and multiple cam struct select function block pairs like this, especially if you're using a cam blend function where you have 3 cams for one axis and possibly even more. So in these cases, and you'll see that this copies once, that's twice, and that's 3 times for those 3 cams. But if you look at any one of these sets of data, we're taking some elementary data, your data values and your formulas, and making a larger master-slave pair to send to the motion engine with this function block. So this data element is somewhat large, and it's only really being used as a temporary container to store the compiled or the calculated formulas before they get sent to the motion engine with this function block. So between here and here, that's really the only reason you need such a data type, such a value. There's no need to make 3 of those YMS cam structs like we have here. We actually have 3. We don't need 3. I could have a generically named cam table, and once I use it in this segment, I could recycle it, use the same name here, and let this function block deposit its calculated values into the same structure, push it to the SRAM, and then recycle it a 3rd time, and that will be 1/3 of the data that I'm currently occupying to do that task. And that works well in, like I say, for cams, but other data types you may not have the luxury of recycling. So, but that's one tip for camming.